Hello, welcome back to BackBit Impossible. It's Loop Darksnout here, and this episode is the Great Graphical Gamble. What that means is, well, I'm kind of making promises I can't yet keep. I have increased my video frames to 2 character sets with 256 characters in each, and I'm also dabbling with 11 kilohertz audio instead of the usual, 8. And yet, my player can't do either of these things properly, not very well at least. Everything relies on this optimizing routine that I have not yet written. So, well, at first, I'm trying to, get the things going under the old system and then optimize the hell out of it and hope for the best. So, let's see how it goes.
There we go. 2 character set, 256 character version. Finally doing the rollout. My first test of the rollout. This is just to see if I can get this thing to play. The color is still being thrown into 2 pages packed like it always has. That will need to improve. And once I stick the sound in here, it's gonna choke. I'm looking forward to the difficulties it'll cause. But first I have to make sure I can get it going, and then from there I can start tweaking. I also redid some audio. I made 2 new files without the track compression, it's called. I guess that's what the feature is that makes things louder when you want them to. I think it was loud enough before, so we'll see. I made 2 versions, one with 76 audio, 7,860 bit rate, and the other one of 11,025. I don't know why that is one of the drop-down choices. It seems to be a popular value. And we'll see what I can afford down the road. But yeah, I mean, after this, I still have to do the audio rollout. Those are separate processes. But cool. I mean, I'm glad this is finally working now, and now that it's going to take, hours to do, it's more PlayStation time for me. Hooray! Okay, it's busy doing the rollout for the audio, but it's doing it the old way. Like, I haven't tweaked this in any fashion yet. I want to make sure that I can get the audio playing in these tiny little buffers the way it used to, with the 3 frames per BBT fetch version, which has 2 character sets, 256 characters in each, before I start getting fancy. And well, I deleted the part. All the source is now gone because it's used for the rollout. But the BBT, the data, was meant to start, the audio data would start at a 32-bit offset of 0, 158, 2539. So, long story short, I set it to 00010, which is exactly the 160 megabyte marker on this file. So there's a 150K gap between the video and the audio. Humongous, basically a floppy disk's worth, and yet in the scheme of things, it's almost nothing. So yeah, got to see if I can get this thing to work, of course. But boy, and then I'll be able to see the difference once I get the bigger audio buffer going. Well, we'll see how well that allows the video to breathe. So it's kind of good in a way. I'm just itching to get this thing working, so I'm doing one step at a time instead of trying to introduce everything at once. As you can see here, I'm now making the, just cramming in the 11,000 hertz audio rollout to code that isn't really meant to play it. Like, it will play it. All I have to do is make 3 lines adjusted in my Impa Final 1.11 player, which will basically negate all the loading of the video stuff, which is not yet ready to play because the rollout is 3 frames per BBT fetch, not 4. And there's a lot of little changes that need to happen in the code, but if I put 3 RTSs in critical places, it'll ignore loading it, which means it won't crash at least, which means I can now use it to play the audio through the existing code that has teeny tiny little 6K buffers. So it'll be, it'll be kind of stressed once I get the video working, but I'll at least get to hear the difference between, 7860 hertz and 11,025. And this will take a lot more space, a lot more time to do it, but well, these BBTs that I'm dealing with, this is back a hold off from the summertime, because I have, like, you've seen the intro where, well, when I hit the BackBit button, it shows like 8730 times the 96K or something. That's because I have 8,730 32K buffers in a row, and then 8,730 64K buffers in a row, which was meant for the original bitmaps with the 5 bits per RG and B component. Long since gone. So I'm dealing always, like, if this is the beginning, this is the end of this humongous, 800 megabyte BBT, I'm always piddling around near the virtual start, really. So at some point, I got to figure out when the true end is, and cut this thing off, because I'm dealing with humongous files that I really don't need to. And it's taken every time I do a backup on my hard drive, I'm running out of space. Yeah, so whatever. I mean, I got so many versions, I'm losing track of what has what and what does what, and this project's becoming a nightmare. One thing I have learned, hopefully for next time, keep better records of what your files are and what they do and what their strengths and weaknesses are, because, yeah, I'm sort of reloading stuff and going, what is this supposed to do? And then I find out it doesn't do what I want it to do, or it was just an intermediate version that's full of bugs.
Want me to go pick some for you, kiddo?
Will you?
I'll go get the red ones on top.
Good to eat.
This is audio level 10 on my louder tweaked version.
No way.
Let's compare it to Wolves on the BackBit.
Oh, the water always tastes so good here. Huh. If only.
As you can see, it's louder. This one is louder. That's with the extra audio tweak that I put in. And then I made these two with no audio tweak whatsoever, and they are significantly quieter. So I'm not sure if there's a balance between these guys and this one, but maybe I'll redo it again. But right now, my next task is to get the video playing on this with Impa Final 1.20, which is basically 1.11 with some tweaks to handle the 6 buffers, because the video is all different now. Yeah, and then I'll go in deeper with the new color compression, do some more rollouts, blah, 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 blah. Lots of work, but it's the final steps are going to be falling into place soon.
Over there.
Okay, this is the 6 buffer version. Playing minus the color updates because that locks it up, but I got it this far. Of course, adding the color is going to create difficulties, but it is playing the six thing, the 6 buffers.
May?
Yeah.
This is the 11,025 hertz audio
This way and that way, kiddo.
with the 6 buffer version, and as you can see, it's glitching out. Even without the color updating at all. Now, one suspect is the fact that, well, there's just too many NMIs happening. But the other thing is, right now it's still dealing with audio buffers that are 3 kilobytes big, and so it has to go refill them quite often when I'm planning to make them 8 kilobytes each. And of course, they're 3 kilobytes at 11,000 hertz. So yeah, they're filling even more than before. 11,000 would be a nice goal if I could do it, but I'm just trying it out. And yeah, it's definitely choking. So, I mean, the fallback sounds good enough, but cool. Well, one reason the color is crashing. This is a color buffer. Well, why is it full of my source code instead of color buffer data? It's not even bringing it in. I got to check my rollout. Found it. This is where the problem is. This is my rollout maker. As you can see, the pack color, I have C, D, and then E and F are reserved. It's meant to be 1K later, and this is the old packed color buffer. So yeah, that's supposed to be that and that. So I completely rolled out gibberish values. Nice. So no wonder my color crashed because, yeah, well, whatever. So I get to redo the rollout again. Here I am looking at the raw BBT data. This is where it begins, right here. And this is load A with 0, stored here, load A with 0, stored here, load A with 0, stored here. Why are they all black? And this isn't the proper buffer. Like this is store, low byte, high byte. That should be E8, F0. I'm not sure what's going on, but I'm just looking because this is where the BBT begins at 2AB40. I want to cut out the relevant bits and reconstruct the BBT so it's not nearly a gigabyte every time I duplicate it, because this is getting crazy on my hard drive. Had to think about this one pretty hard. The reason it's 0 and 0 and 0 because this is the rollout based on the flawed color. Man, yeah, that was a tricky one. So this is not something I can trust. I have to go back to my previous file on this.
I don't even like goat meat.
I don't believe you.
I'm telling the truth.
I still don't believe you.
Well, this is the first time I've done something on this program in about a week. Only a little bit on paper, but this is the reloaded version 3 now. I finally did the rollout for the six frame buffers, 2 character sets, 250 character set, 256 characters in each. I also did the rollout of the audio. This is without any creative byte skipping stuff. I just wanted to make sure this thing plays. For some reason the color doesn't work. I can't remember why. I'll have to dig into this later. This has been one of my first plays since the rollout completed. At the moment, the larger audio buffers is not happening. I just specifically forced it to do the 3K buffers like before, because I want to just quickly tweak it later to see what difference it makes when I do switch it to 8K buffers. But first I have to get the color to work, because that's when it'll start to choke, and that's where increasing these the audio buffers and creatively looking for duplicated information in the frames themselves that I don't need to carry over, when that starts saving me bytes as well. All right, this is pretty crude, but this is my first optimizing program. Let's see what it does. It starts at frame 6 and loads in the character set, both character sets, top and bottom, and the video matrix for 6 frames ago. So frame 6 looks up frame 0, compares every byte in each character set and the video matrix, and adds up how many are the same, because those are the ones that don't need to be re-rolled out. And if I hold the button here, it'll show me the stats. At the moment we have frame number of bytes that are the same in the top character set, number of bytes same in the bottom, and the number of bytes that are the same in the video matrix. Now this is just a simple comparison. Load in, compare, spit out data. Easy enough. So I'm doing this because I want to get some baseline data as to, if I did nothing, this is how much I could save, because I could make the rollout, compare, and if the values are the same, don't bother rolling them out. The rollout would have to operate a little differently though, because it's doing it sequentially, when in this case I would have to be kind of skipping along, comparing stuff to 6 frames ago. There's a pain. It's going to be a pain. I know it's going to be a pain, but it'll be doable. And the frame changed. So is the data more likely to be the same. That's nice. Probably because the sky, right? There's a lot of savings in the sky. I'm just going to keep jumping in here. Okay, I got to stop doing that. But so what's the good point about this? At the moment it does nothing, but this is called optimized because I do plan to, after it has a frame and the 6 frames ago, massage the current frame move characters around in a logical way and make it so the amount of characters that are the same as the previous character set are, quote, optimized. And I do have a lot of, well, it doesn't really matter. Maybe I'll show it on the screen at this point. A lot of the code worked out. And when I'm done, I think, is it this one? Yes. This will regenerate. Or was it this? It's something here. Don't worry. It's a lot of paper. I do have a lot of stuff done on paper. Pretty much the code is written. I just have to enter it and make sure it works. And then once you have the massaged, switched version, it's the same picture. It's just the video data has been shuffled around. It'll make the same picture, but it'll be better for this stuff. Hopefully these will get better results. And then I can just rewrite that frame to the BBT exactly where it was, and with the same rollout logic, looking for similar bytes to not roll out. With a new rollout program, I can also make this more efficient in the end. Hopefully all in an effort to save those precious bytes I need so the watchdog can stay ahead of the interrupt. Yeah, I mean, whatever. This is a silly waste of time, but I'm really itching to get this done now. But I got to remember, keep at it, because if I piddle along, time keeps going, right? And there's other programs to do. And my Commander X16 moves northward continually. It's out of Texas, but it's still in a different state. I forget which one. But by the time it gets here, yeah, I'm going to be so distracted it'll be painful. So I better get this done while I still can.
So there we have it. We left off, doing a little comparison thingy, seeing how many bytes are the same. It's not optimizing yet, but it's checking out what savings are possible as is. That's assuming this optimizing code works and I don't, give up because it's super complicated. But in any case, I guess we'll have to find out, because I do have an episode, with optimize in the title, so I'm sure that has something to do with it. Anyway, till next time, I'm Luke Darksnow.